Let's talk about PM generators or magnetic pulse generators. They go back all the way to a 1972 Chrysler with electronic ignition and still utilized today. The highest popularity of using a magnetic pulse generator, sometimes referred to as a variable reluctor, are wheel speed sensors. We can also find them as crankshaft sensors, camshaft sensors. Their electrical device is a PM generator, variable reluctor. They'll always have two wires. It doesn't matter which wire you tap into, you're going to get the same waveform. You should couple your scope to AC because it does produce an AC waveform to give you the best resolution when looking at it on the scope. What I have here, and I told you in the beginning that the Autel can either be utilizing the tablet with the 908 as I have here, or it could be using a laptop. This was a vehicle a week ago that came into the shop with a wheel speed sensor problem. And as you can see, the red line is the right front and the green line is the left front. And I had a code for the left front wheel speed sensor. Look at the difference from the rise of the mountain to the bottom of the valley. The rise of the mountain to the bottom of the valley is called peak-to-peak voltage. As you increase the RPM of a distributor, crankshaft, camshaft, wheel speed sensor, the amplitude will increase. Now the language of a computer is digital. This is an analog AC waveform. So either the electronic brake control module, a computer, depending on the application, somewhere along the line, either internally or externally, there's going to be an analog to digital converter. And it's going to take this analog waveform and basically shape it into a square wave, because a computer is totally digital. Anytime that you have an analog AC waveform, it's going to be converted to digital. You'll also notice that a lot of times an AC waveform, such as wheel speed sensors, cam crank sensors, pickups in the module distributor applications, they'll be wrapped in aluminum foil. This is to keep out unwanted electromagnetic and radio frequency interference and doesn't upset the goodness of the signal going back to the module that's either turning it from analog to digital or internal in the computer. So that pretty much wraps up the AC waveforms. So if you know that it's a two-wire magnetic pulse generator, AC waveform, variable reluctor, you can tap into either side and you can generate this signal. The slower that you can move the item, the weaker the signal will be. You do have to have a handshake between the analog to digital converter and the PM generator. There has to be a certain amount of peak-to-peak voltage. A lot of times that specification is not easy to find. That's why I compared the right versus the left. Compare a known good pattern to where the problem is. Another analog signal I'd like to talk about comes from a piezoelectric device known as a knock sensor. It is a tuned crystal set up to the frequency of engine detonation or engine spark knock. So the knock sensor produces its own voltage. It's an analog waveform. That's going to have to go into an analog to digital converter. The peak to peak, the greater the signal, the more the digital signal will provide information to the computer, and the computer will know the severity of the knock and go in and retard timing to protect the engine. The older knock sensors had a wide range of pickup. You could tap on the engine with a hammer and a lot of times get a signal, but these newer engines, and the vehicle that I have here is a Ford Fusion with the late model direct injected EcoBoost engine. The frequency of spark knock is tied very closely to the knock sensor. So unless your hammer is going to equal the same wavelength of noise as the knock sensor going off for detonation on this particular engine, then you might get a signal change. So I'm tapped into the knock sensor. You can see the vehicle's not even running, but I'm already generating a waveform analog signal. And the computer will monitor this for output. We'll get intensity, the peak-to-peak voltage will increase, we'll get more pulses, and the computer will determine this, whether or not the engine is detonate. And then it can go in this application It can reduce boost pressure. It can open the throttle or close the throttle farther to protect the engine, and it can retard timing. So we have fail-safe, and this engine actually has a knock sensor 1 and a knock sensor 2 strategically placed on the engine and set up to a frequency equal to the knock on this particular combustion calibration.